Other things, ATA standards. And I don't care about all, there's a whole in-depth value of ATA standards, and I don't want to go into all those. What I want to tell you is what's important to us. And so when you're going down the list from the beginning of time, then we went into Windows 3.1, then we finally got to Windows 95. We started adding faster high-speed access, so we had DMA and UDMA. Really, that wasn't until mostly Windows 95. And then after that, we've now switched pretty much to everything being DMA or UDMA. But you can still use PIO mode. Now, this is just a way to talk to the drive faster. Programmed Input-Output Mode is what PIO stands for. And that was our original way of communicating with the drive. If we're using DOS, there's not a lot of drivers, there's not a lot of fancy stuff going on. We're just doing Programmed Input-Output Mode, talking to the drive over the bus through the CPU and having some communications that involves the whole machine. Whereas UDMA, we can actually talk directly to the board and make some memory transfers, and it's still, even in Windows 7 or any other version, you'll still see that if you actually go into computer management, and it's still, even in Windows 7, you go to your adapter, you go down to your ID adapters, and if you go to your channels, you'll actually see that in the channels, you'll have advanced settings, and you have the option of switching from DMA to PIO mode. The reason I'm bringing this up is, remember when we first got high-speed CD-ROMs and they came out, but people were having problems with jitter and sound, and the answer to solving that problem was to drop back to like 1x and 2x speeds when you write your disk. And we have similar issues when you consider that DMA and memory and stuff like that, they have problems. They're cheap chipsets, maybe bought for 25 cents, and maybe you're going too fast for it. Maybe there's actually some problems. Maybe that's actually where the problem exists, that there's a bug or it's a crappy piece of memory. And falling back to PIO mode and going back to old school methods of talking to the drive, actually, even though it's slow, works. So half of the time, I will tell you, when I have a drive in, if I switch to PIO mode, I can probably copy it better than I can in DMA mode or UDMA mode. So it's just one more option on the list. So that's one of the first things, is changing your speed by dropping down to an old school method. So I could do this, even on a Windows machine right now, I would have a secondary controller. Don't do it on your primary controller because you need Windows to boot and do all the normal stuff. I could have a secondary controller in the computer, and I could hook up a drive in PIO mode without using any special tools or anything, and I could run something on it to copy the drive. And in PIO mode, I may get a lot better response, or able to copy a drive I could not copy in DMA mode due to some memory problem or some chipset problem or something else. Good? Everybody all right? So that's one option. And you can do that, if you have a Linux machine and you're playing around with settings and stuff, you can make all this stuff happen with some Linux commands. Pretty quick, pretty easy, pretty automatic, but it does take some work to understand all the commands and all the things you can do. So next thing is, as we continued on, we had an older way of talking to our hard drives. So I told you everything that's like earlier than 8 gigs, that's ID hard drives. We did basically CHS, cylinders, heads, and sectors, and we had a different way of talking to geometry, but we switched to LBA 28-bit mode. LBA 28-bit mode, logical block addressing, is what SCSI already had. So when we finally got here, we were doing it in the way that SCSI did it. And it's very important that because everything we talk to from this point on is all LBA. So LBA 28-bit mode or LBA 48-bit mode. And one of the things that happened is LBA 28-bit modes, if you're using, it was really 32 and they used 4 bits for something else, so they reserved some. So it was 32-bit, and then we went to 64-bit, but then they reserved more bits. So now we're at LBA 48-bit mode. That's what we currently use. But LBA 28-bit mode is how many bits you can count, basically. How big can you address your drive? And in LBA 20-bit mode, the highest you could address is 137 gigs. That was the highest you could address. Well, we never had a 137 gig drive. That never existed. So if you ever see a 137 gig drive, it should go off in your mind that somebody took a new drive and put it on LBA 28-bit mode because it fell back and it will actually knob off the partition structure. And so if you have a 200 gig drive, and this was the problem back in the day, some of us that were doing this and old enough to remember, if you bought a 200 gig drive, when you would get it, Maxtor would send you a card. You get a promise controller or something with it, because your BIOS did not support it. Your BIOS had not been updated. Most machines at that time, there was no patches or anything for. They made you buy a new machine. So you would use a card that would actually extend the BIOS so that you could actually talk to this device over LBA 48-bit mode instead of 28-bit mode. So if you took a 200 gig drive and you had a partition structure on it and you put it in an old machine, now you had a 137 gig partition. It would actually modify the MBR, and so you would end up with a drive that you could not access the rest of the data from. That was actually data recovery back in 2001, 2002, was just to ignore the MBR and copy all the data the way it was. Because there was no actual problem, just that it modified the MBR, because it could only count that high. Everybody good? So, there is one major important thing. In LBA 28-bit mode, they had a command. It was called ignore ECC. And so what that means is you have a sector. It's 512 bytes. Still today, even though we have bigger sectors, it's still 512 bytes that's delivered to you logically. So everything still delivers 512 bytes to you. Good with that? Then there is 4 bytes of ECC. Some drives have more, but it's essentially 4 bytes is necessary for 512 bytes to work. So 4 bytes of ECC. If the sector was read and there was damage, and ECC did not match it or compare, it's error correcting code, error correcting, it will just say, I am damaged. I cannot do this. And so it will throw away the answer. So this is how you are having bad blocks. Right now, when you go and you try to copy something and it has uncorrectable error and it errors out and fails, it's because something was read that did not match ECC, it threw it away, or tried again, until the threshold was met, and then it says I failed, and I did not copy that block. That's a bad block, okay? So, what you could have done is you could have requested the sector and said, I don't care what your error is, give it to me anyway. When you do that, you have a guess. And it's not really a good guess. It's kind of a crappy guess, but it's a guess. So what some of the vendors did, and especially the DeepSpar, what they decided to do was create an array and request that sector many times. Then take the array and compare it and see how many times you have a win scenario. How many times did these bits all match? Because there is nothing in the hard drive or nothing in the system to do that at all. So they had to collect the data, then compare the data, and then figure out what the win scenario is, and then save that sector. So it is a guess, but it can become an educated guess. And it's pretty decent. It's not perfect, but it's pretty decent. You can actually see it resolve the problems. So it can physically actually do that. Not every drive supports the command, like Samsung's do not support the command. But a lot of them do. Let me see how many. I'm going to try, see if I can do one, and then I'll show it to you. No, just try it. You can choose.
Really?
Yep. Yeah, so you can decide on a DeepSpar, I think the highest is 99. You can tell it to do it 99 times. So, 11 I think is the default. 11 I think is too low. But the question is about time. Let's say you have 1 million bad sectors, and you need to deal with 1 million bad sectors, and you tell it to read them 99 times. It's going to take a really, really long time for you to recover this data. So if I only have 75 bad sectors, I might tell it 99 times because I will get a very robust recovery. And if it's like in a JPEG or something like that, you won't even notice the problem. You'll recover the file, it'll be fine. But if it's in a DLL, that machine's not going to boot and it's not going to run correctly in that file. So, but it may be close enough, especially for forensic purposes and things like that. In many cases, it resolves the problem. It really depends on the type of drive and the type of damage. But that's kind of the thing that separates me from most of the other people who, like, if they don't have that capability and they can't do it, I actually can get data back that actually might mean something, as opposed to forensics people who say, I just have 0. Because all they're getting is 0 for those sectors. I'm getting something. And sometimes it's readable. It's readable text. It's a password file. It's a spreadsheet. It's something where I can actually then still determine that there's enough data. You get enough zeros in a spreadsheet, it won't open. But you get some data, you might be able to correct it. Even the software may correct it or repair it. So you may have a situation where you can do that. So it's important to note that this is one of our other options that we can do. And I'm not just telling you stuff, we're going to do it. So LBA 28-bit mode, then moving on from there, we ended up going to LBA 48-bit mode on the next one. But when we got to LBA 48-bit mode, they got rid of this command. Now this command, ignore ECC, is also known as a long read. That is what it is called. So most of the time you will hear, can you do a long read on it, or ignore ECC. Those are the same command, long read or ignore ECC. Okay? There is a new one that is called long physical sector. So don't confuse long with other commands. Long physical sector is a 4K sector. When we have new drives that actually expanded from 512 bytes, 2009, 2010, they now have a 4K sector. It actually natively is 4K in the drive, but to you, it's still 512 bytes. Okay? We'll get into that more tomorrow. And then Smart comes along, and there's now also an extended Smart. So Smart actually has some really extended capabilities that it can do some really good stuff. Most of them are disabled, but there are things that you can do with Smart now that you could not have done before. But the biggest thing is that you have Smart. Smart in and of itself is not really useful to you. It's only collections of data. So Smart doesn't do a lot for you, but Smart can also be the reason that the drive died. The self-monitoring, analysis, and reporting technology, when the table is being updated to tell you this information, if the table gets corrupt, let's say it's powered off at the time that it's writing something, and for some reason it can't finish writing it, it can corrupt the table. And it is so often a problem, it has become a common thing for us to do to erase the table as one of the first procedures in doing data recovery. So in hardware tools, all the hardware tools that have access to the system area, they will have a button that says to clear the Smart table and restart the drive. Because that, what happens is, your drive starts up and you have a piece of hardware that's embedded and it's reading some data, and the data is corrupt. It will actually crash. And when it crashes, it actually goes to a prompt. It actually will fail, and there will be an F prompt. If you could see it in the terminal, you'll actually get a prompt. Some of the drives you can see it in the terminal, some of them you can't. But when it fails, the drive just completely aborts itself. It can't do anything else, won't deliver anything else to you, it just fails. So the Smart table may be the reason that that's corrupt. So that's one of the first things that people do, is clear the Smart table, start the drive up again. I'm not going to say real often that that's what the problem is, but it's often enough. And the Smart table was also involved in part of the firmware problem that the Seagate 20, the 7211 drives had. That's one of the first features that it does in the updates also, is clear the Smart table and get rid of all the data. Start all over again. But the Smart table does also keep track of the bad blocks. So that's another feature of that. Then host protected area we started talking about. Compact flash memory sticks have their own ATA standards, so they can be done as hard drives. So if you ever see a compact flash come in for a recovery, be like, that's awesome, woo, because I can do a recovery on it that I cannot do on an SD card.
It doesn't the same apply to NAT?
To what?
PCMCIA cards?
Yeah, but at least have an interface there. You have something you can talk to. So if you're dealing with those, you can see those as well. So those are all hardware based, as opposed to SD cards, which don't fit into any of these ATA standards at all. Those are all coming through a USB standard. So yeah. And then we get to LBA 48-bit mode. LBA 48-bit mode will allow you to access drives greater than 137 gigs. So understand that if, let's say, you have a 1 terabyte drive, the first 137 gigs can be accessed using the old method of LBA 28-bit mode. And if they support the command for long read in the drive, you can read that content for the first 137 gig more accurately than you can the last terabyte of the drive. Okay? The value is the most important data almost always is in the first 137 gigs. Your MFT tables, all the stuff that has to do with the file system itself, and a lot of the stuff that you've started storing is always going to be towards the lowest LBA numbers. Microsoft tools, Microsoft embedded in from Windows 2000 and on, earlier versions used defrag, and they would defrag a drive, and you remember on defrag it would pick stuff up and it would say, I'm going to make it contiguous, and you would get this picture of your disk and it would move it all to the outside edges. Well, that's why the outside edges are faster. So Microsoft built in performance routines into Windows 2000, and so Windows 2000 and Windows XP and everything forward from there all take a look at the data and live in real time all the time. Because like, who defrags their drive on Windows 7? Not really, right? Like, nobody's really messing around with it anymore. Windows itself automatically will look at the performance stuff and say, you opened this Excel file 75 times, so I'm going to start shuffling that stuff to the outside edge of the disk. So it will use performance enhancing routines to move data around towards the outside edge of the disk automatically on its own. So you'll start getting that kind of stuff where it will physically start moving into that lower blocks and does automatic defrag routines unless it's solid state. Okay? And so that's why one of the things becomes very valuable is what we can do with the 137 gig. Now, I happen to have Hitachi or Toshiba. Yeah, this is Hitachi. Some drives, especially some laptop drives, don't support all different modes because not all of this stuff always existed back in the day. But on 137 gigs and below will be on most 3.5-inch discs, except for, say, Samsungs. So that's one of the other advantages. Then moving forward, we have other standards that we don't have to worry much about. But those are all the things that matter to us. So of the 4 things, out of all the stuff that we just talked about that's important, is PIO mode and DMA mode. This is kind of like finding the sweet spot for timing. This is really what this comes down to. How fast can I copy the drive? Because it may take 2 months for you to copy a 1 terabyte drive, and if you play with some of these settings, you may be able to get a better setting that will be faster and will complete in a week instead of 2 months. So this is all about finding the sweet spot where it's not broken and it actually works. Okay? Lots of problems with drives today, and sometimes finding, you know, a different DMA mode actually makes a difference. So that people can kind of see what I'm looking at here. It's like, this is one of the settings that's inside of a DeepSpar, and so you have your DMA modes, and then you have your UDMA modes. Well, whatever the drive supports is the highest one, it's going to automatically choose. So it's going to say, my drive can do this. But if this turns out that this doesn't work, and I switch back to PIO mode, and I turn off DMA mode, I might actually get a really good read. But it may be really, really slow. So in this particular case, I may want to say, I'm going to manually make a decision, and I'm going to say, you know, okay, well, maybe UDMA 1 is a better choice because it's fast enough that I can do something, but it doesn't fail. But I have to kind of test that in the scenario. So there are some times where certain things work automatically, and other times where you want to manually make these choices. And every tool supports these types of settings. The PC3000, there is some settings inside the Atola to do some of this. Dimitri has fought with me a couple of times about PIO mode, but these are important features that actually make a difference on certain drives.
Does DeepSpar also have a setting where it automatically falls back to PIO mode?
Yes, it will automatically. Initially, it has 3 passes, and 1 pass is in PIO mode and 1 pass is in DMA mode by default. But you can make, yeah, it does the first pass as fast as it can, so it'll do it at the highest DMA mode that's available, and then the second pass will clean up all the problems using PIO mode. But you can make those choices yourself or modify the subset of possible choices, because the third one will do long reads. So the third one says, all right, you did all the ones you can do with DMA. Now you've done all the ones you can do with PIO. Now let's clean up the handful of problems that are left using long reads. Now, you may want to make other choices, and I suggest you do, but those may be acceptable.
So it just fills in the gap. So you do a quick scan of drive, get everything you can, and then it comes up with, I have these 30 bad areas that I can't get shit. So I'm going to go back and try a second pass only on those 30 areas, and then finds 20 of them, left with 10.
Yep.
And then it just goes on a pass for those 10. So
exactly.
You're not trying to do the whole drive in PIO.
Exactly.
Cool.
You are only, if it ever turns green, On all data recovery tools, if you've ever touched it and cloned it, you never touch it again. You've touched it, you cloned it, all you're doing is filling in the holes.
Yeah.
And so because LBA numbers are sequential and they have a position, at any point in time, if you say I want a copy from LBA 25 to 55, it's always in the same place. And it always writes it to the same place. It's always 25 to 50, so it's always the same. So when you're filling in holes, people sometimes get a little confused by that, like we're filling in holes. If you're only filling in the holes for the same position, so you don't have to keep track of stuff and try to concatenate things yourself. There are times you can do that, but that's the other thing is that since they're all position oriented, when you copy them, you're only filling in the holes for the ones you're missing. So I think of it, the easiest way to think of data recovery tools in my brain is they are BitTorrents. So it's the DeepSpar is a BitTorrent for a hard drive. It fills in the positions for the ones that are missing, and you're getting all the best scenarios that are the most likely first, and then you're whittling away at the ones that have problems till you actually get them. Now, BitTorrent actually does the opposite, though. Actually, what BitTorrent does is the ones that are the most likely to fall off of the tree first are the ones that it duplicates. So it thinks of it as you only got 6 people that have this file, but 700 people have this other, so I'm going to increase the count for the 6 people that only have this one piece, so let's get these first, and then get the others. So kind of it does the bad first and then the good. In our case, we're going to do the good first and then the bad. And the reason being is, all these forensics imagers, they go contiguous, and if they're grinding on a drive and it dies in the Windows system folder, who the hell cares? It's worthless stuff for the most part, right? What you want is the user directory. So let's go get all of the good stuff first and then come back and get the stuff that's bad as fast as possible. So, and then it'll just whittle away at the problems that are left. So in this case, like this one that I'm on, like I tried to do a long read on this, it got errors and aborts. So I actually have good stuff and then I have bad stuff. And if I keep on going forward, if I had told it to just keep on going, and let it do its thing, then it would have automatically done all those as green, leaving the hole, and it goes so fast, I'm so far away probably. Leaving the hole where the bad stuff is, right? So then the next pass, it would try to clean those up. So I'll manually add those, but I could say, okay, fine, it made it past that junk. Now, I'm going to make a change just so I can force it to do it. So I'm going to force it to read the abort errors going backwards. That's what would, like in different passes, you will have different sets of errors where you can do that stuff. So now in this case, I'm going to go backwards from where I'm at, and you'll see that it will fill in and read all the A's. And so the number went down to 0 again. It was actually tracking that number with the aborts, and I had a certain number of aborts. I can make it happen again. I can manually cause them to happen. But it cleaned up the stuff in between in the holes. Good? Everybody understand? And those are the variety of ways that I handled that is what modes am I in. Now the modes are actually tracked, and you can see them on the screen. So P is PIO, D is DMA, 4 is 48-bit, 2 is 28-bit. So you can actually tell what mode you're in at all times, and you can manually change it in different scenarios. See, I'm in forced PIO mode instead of DMA mode, so I have an option to actually select and check it, and I can do it on the fly. So I can tell it on this pass do this, on that pass do that. And I don't have to restart the machine or change configurations or do any hardware or anything like that. If you're going to do this in Linux and you want to do it the Parman's way, you can use HDParm and you can mess with the commands, you can mess with stuff on the fly, but you're going to have to script it or figure out a process to do that manually so that you'll go through those processes, then run ddrescue, and then do it again. Then change all your commands and then run ddrescue again. So there are certain things it will do, but ddrescue doesn't do everything. And there's a separate version of ddrescue that uses scripts, dd_rescue, and there's a tool called ddrhelp. And those will actually run different scripts and try to do that timing stuff for you in Linux. So if you want to do it, it's possible. It just may, like you can't control a couple of things. So for instance, DD rescue, you cannot control power. Right now, and there have been people, and I put it out there a couple of times, you could control power if you wrote it into the piece of code to actually flick a port, that you could actually use a relay on a port, turn the power off, turn it back on, and then start back where you were. It's possible, certainly plausible. I mean, I wrote stuff like that back when I was in high school to do it with parallel ports, so it's possible to do it today. But it doesn't do it by default, and it's not in there. The second thing that's not in there is it can't deal with heads and LBA blocks. It can't say this zone is on this head and this is bad, so let's ignore this. They don't do anything with that in DD rescue at all. That is one of the most powerful features in a tool like a DeepSpar or PC3000 or these others, that I can turn on and off heads. That I could actually say, oh, I've got, in this case, and I know I'm jumping around here, but I'm going to just show you, like, I have this, I have a Hitachi drive, and it's going to actually go and look at, and it's not a perfect scenario, but it works most of the time, like 95% of the time this will work. It's actually looking at my heads and the zones that I have and trying to figure out where all the LBA blocks are on which heads. So it's breaking that down right now, and so now when it's done, I actually have a head map. So this number over here in the corner tells me what head I'm on. So if you look at the row, so if these are how I'm transferring data. This was how fast I transfer data. This is which of the passes I'm on, because I can manually program 4 passes. This is the LBA blocks where my cursor is. Where my cursor is blinking, that's the percentage of where it's at. It's not a percentage of how much I've done. Don't confuse that with percentage of how much you've copied. That is not a percentage of what you've copied.
Where the cursor is